So yeah, today's problem is a pretty tough problem. I really struggled to solve this problem. It's extremely hard to solve. I mean, even after we figure out a lot of how to solve this problem, then also, I mean, there are just test cases and requirements, time memory requirements which are pretty hard here, especially the memory requirements. So I'll get to that as I move through this video. But yeah, this is a pretty hard problem, and on the top of it, I think if you look on YouTube, you have pretty few solutions of this, and whatever solutions maybe uh, online that I can find are pretty complex. There is no very I mean readable solution that is available for this problem. So in this video today, so we'll go through these steps which I'm about to say. So first, we'll basically look at what the problem is in very short, right? I'll just give you a crux of the problem, and then after that, I'll give you a very important intuition which helps to solve this problem, make the code much more simpler. And then after that, we'll dive into the code and dive into the various optimizations that I did in order to solve the problem. So let's so first step is what is the problem. So basically we have a set of characters, right? I mean, we have a string from which we can extract frequencies of characters. So we can basically make these characters, right? Have these characters kind of, and then our goal is to somehow use updation, deletion, and or insertion to make the frequencies of all the characters equal or zero. Either it can be equal or zero, right? And then what should be that equal frequency? That can be anything, right? There is no limit to it, so that can be anything. But as long as all the frequencies are equal or zero, we are okay, right? So let me move this around a little bit just to give a very simple example. So in this case, in order to solve this problem, I think if I just delete this, right, or move this tile to the next, I'll be done, right? So I'll be done. So another constraint is we can only move the tile forward. I mean, we cannot go backwards. So if you want to update a tile, so what I did here is, suppose this was A character, B character, and C character. So I basically made B character updated to character C. We can only update to the front, right? Uh, and then put that updated character here, right? We update to the next character and put it here. We can only update to the next character. Okay. So yeah, so that is it, right? So this is what the problem is. Basically, you have characters, and then either you make it all same or zero. And now coming to the intuition, what is the intuition of the problem? The intuition of the problem is this. This is regarding the update or the carryover tiles. Let's call each of them tiles, right? All of this, let's call them tiles or blocks, just for sake of ease, right? So the point to be noted at is, let me redo this scenario. Okay, suppose our scenario was this, and what would one possible solution be? We can basically delete this tile. We can or update this tile to the next character, right? We can update this tile to the next character and further update this tile again to the next character. So let me delete that again, and then update this tile to the next character. You see, right? So basically we did two operations here. But is this really necessary to track this operation? Because we could have done some other thing. Okay, let's go back to the original position. Sorry. Yeah, yeah, we could have done one other thing. We could have just deleted this tile here and then inserted one tile here. So carryovers for more than one uh, I mean, the same tile carrying over for more than one character is totally unnecessary, because there are other operations which can capture the uh, same, I mean, resultant operation with the same efficiency, right? For example, if I just delete this here, if I delete and I insert, I have exactly two steps which I already had earlier, and then I have the same result. So the efficiency is the same, and there are some insert and delete operations which are tracking the same. So we don't need to really track carryovers, or let us call it carryovers, right? Tiles which are carrying over from one to next character for more than one, like, character change. So, right? So this will be more clear when I move to the code, right? So this is the basic idea. So now let us, for the third step, let us move to the code and try to see how we have solved this problem. First of all, okay, so we'll start with, so okay, so what is uh, this loop? So basically, you remember, right? We had like two choices. So we had, the scenario for solving the problem was either all the tiles will be having the same quantity, or all the tiles will have zero quantity. Now, what is that same quantity? Like, we don't know, right? So basically, we can try from 0 to the max frequency of the characters that we have from our string input, right? Or the max tile size initially in the input. We basically we will go through that, and then and then from 0 to that, to a certain max frequency, we'll try out all the values and see for which value we have the minimum value, like, for which value we need to make the minimum number of steps, moves, whatever, right? Or minimum cost, and that would be our answer. So that is the way that we'll do it. So yeah, starting from line number 39, we first obviously here we are just capturing the frequency of every character in the input string, and then we are capturing the max frequency. Why do you get the max frequency? Basically, to kind of uh, uh, find this value, because this value is required for this for loop, because that's helps us define our range, right? uh, of the values that, or the target values which we'll try to find an answer for. Here the range is defined, I mean, the right most border of the range is the max frequency here. Okay, so this is that. And now coming to the solve function. Okay, okay, before that, one very important thing is for memory constraints, we could have used a vector int of we could have used something like this: vector int, right, something of this sort, or vector long, right, and then dp, and then 26, and then vector long, then probably s dot length, right, length, and then plus one comma minus, something like that for the dp array. But we can't use this because for every I mean character, we have this s dot length stored, right? And then if you go to very the test cases which are at the very end, then we'll basically run out of memory. So because we don't need, because basically this stores the carryover value. I'll come to that in a moment. But these carryovers can only take some values, it will not take the entire range. So if you just populate every value, most of this will be unused, and it will be unused memory, and ultimately that will result in the memory overflowing. I mean, the test case would have been far more kinder, but for this particular question, the test cases are not that kind. So you need to take care of this optimization, otherwise all your test case won't pass. So that's about this optimization. Now let's look at what this solve function does, right? So basically, what it does is, okay, if after index 26, if you have a carryover 0, then basically you have found a valid solution. It will return 0, or we return int max. Int max is basically to discourage this particular from wherever whichever function is the caller of this function is discouraged because it is giving creating a situation which is not, which is basically not solving our case. That means after all the characters also we are having some leftovers or or carryovers, which is not what you want. Basically after finishing of all characters there should be zero carryover, right? Because you're done with it, there should not be any carryover. So that's why this code is the way it is here. And then this basically was just DP optimization, like, and then we initially set best to int max because we're trying to calculate the minimum value. Obviously if it is equal to target, then we do nothing, right? Basically do nothing, and then you pass it as it is to the next index, right? And then now comes our three operations: delete, update, and insert. Let's come to update first, because here we are using the uh, concept that I already explained just before explaining the code, right? So what is the concept here? Concept is we don't really care about the carryovers when we are talking about update, because what update does is we are basically relabeling the current tile and moving to the next character, right? So the carryovers are already relabeled once. So we already showed that if you relabel something twice, there are other operations we do which basically capture the same efficiency, so we don't need to do it again. So hence we are not concerned about relabeling the carryovers here, only concerned about the original tiles that were there, because they will be relabeled only once. This is a very important concept which helps to simplify the code here, right? Okay, so now obviously if our current tile is greater than the target, then obviously we will what we will try to do is we'll relabel uh, the balance and then move to the next character, right? On, and if our current number of tiles are less than target, then obviously we'll have to relabel everything, because then you have to convert everything to zero, and then we basically relabel everything. This is the cost for relabeling everything, right? And the previous thing, this was the cost for relabeling only the extra things, and then we move the relabeled things as carryovers into the next kind of character, right? And then let me explain insert now. So what happens if your index is less than target, right? So we'll try to insert some tiles, right? Insert the some tiles so that it becomes equal to target, and basically we are passing 0 to the next kind of next character, because if our f index is less than target, then there is nothing really to pass to the next character. And then we also have carryover, so we try to incorporate that carryover also. And then if we sum up f index, the current tile number and the carryover, then whatever balance is there, that is required to be inserted. And then if the summation is more than target, then basically we don't have to do anything, right? And this particular code takes care of this. Yeah, because if the summation is more than target, this will become negative, and that's fine. That means we don't have to do anything. So we'll have zero here, and then max and zero negative will be zero. So basically, the answer will be zero, which is exactly what we want in this situation when the when the summation of carryover and the current tiles is greater than target, right? Here also we don't try to move the carryover to the next step. So I mean, uh, so yeah, anyway this is okay. So during insertion anyway that is invalid. So yeah, so the crux is basically we try to use carryovers so that we can reduce the number of tiles which can be inserted. Okay, so this is about this. And then finally coming to deletion. So if our index is greater than target, we try to delete the excess, right, and pass zero thing, right, because we have achieved target. Or what we try to do, we try to delete if the current number of tiles is less than target, we try to delete everything, because that will bring the current tile number to zero, which is one of the valid states for a particular character. And then basically then that's why the cost is the current number of tiles, and then we'll pass zero to the rest, because we deleted everything. To the next, we pass zero to the next character, we have to, because we have deleted everything. So with this, I think I've explained the code. This is an extremely hard problem, I will again say. and this is this very uh, difficult to come up with trick, which is like once a carryover done twice for single tile, two time or two, I mean labeling it single tile twice uh, basically carries no value in the context of finding the best answer, so we don't do it. So right, and then this code is pretty simple and pretty short. Hope you understood this code. If you have not understood it, probably you can rewatch this video and think about it a bit. I think I'm pretty sure you'll grasp it, but it'll still remain a difficult problem, and it's easy to forget about this. Right. So I hope to see you in the next video. Thank you. Bye.